To this week's video discussion. So this week we'll be discussing short field takeoffs. We are going to simulate a learning situation where I'll be teaching a student about short field takeoffs. So the way I would approach this, I would start by discussing the what's and the whys behind the short field takeoff. What is it? What is this short field takeoff that we're talking about? It's a takeoff and climb from fields where the takeoff area is short, restricted, and it requires a maximum takeoff performance. So let's say there is a bunch of trees right at the end of the runway, or the runway is just about 2,000 feet or less. These are situations where you want to use short field takeoff. Now, why do we practice this so much? It helps us develop the ability to operate the aircraft at its limits. So what you're doing, you're using maximum performance climbs and takeoff. And the aircraft feels weird sometimes when you're in those configurations. And it also helps make the students more comfortable with the aircraft since you're operating it at its limits. And helps us also fly to different airports that we weren't able to fly to before. We are able to increase our personal minimums as we are learning more and more, and we can go to airports with shorter runways. All right, so there's two key components to this short field takeoff. There's the best rate of climb versus the best angle of climb speed, and also runway selection. So what is the best rate versus the best angle? So we're talking about V sub y and Vx. What Vy is the highest altitude, or the speed at which you can gain the highest altitude over a given time. And Vx is the highest altitude or the best angle to climb in order to gain the best altitude at a given distance. So that's what we need here. It's a short field takeoff. We don't have a lot of distance. So we want to gain the maximum altitude in a short distance. So we'll fly Vx. And runway selection, it's all about understanding your minimums, the aircraft's limits, as well as the environment in which you're going to be flying into. So pavement quality is a good example of what you need to keep in mind. Forecasted winds, you want to make sure that you're not going over your personal and the aircraft's maximum crosswind limits. And just get a good understanding of the whole picture, and we'll be choosing and selecting the correct runway. All right, so now let's talk about the takeoff itself, actually. So we want to be configured based on the POH. Most aircraft call for 10 degrees of flaps for this. We want to also make sure that we are utilizing every bit of the runway that we can. So we'll be pulling off to the end of the runway as much as we can. And we'll line up, make sure that the nose is level and we are on the center line. The next thing would be to hold the brakes all the way, apply full takeoff power, and do a static engine check. What that means is, as you're going full power or takeoff power, depending on your aircraft, you'll be cross-checking all the engine instruments, you'll be cross-checking all the parameters, making sure everything's in the green, making sure you're getting enough thrust. That's the most important thing for this takeoff, since it's a maximum performance climb. We need the maximum amount of thrust that we can possibly get out of this engine. We'll give it a second. We might have to lean the engine just a bit to get that maximum RPM depending on density altitude. And after you're satisfied with everything you're seeing, that's when you release the brakes. So we're rolling down the runway. We're using right rudder and left rudder to stay on the center line. And we are calling out our calls. Airspeed alive, engine instruments in the green. A lot of people just say that, but we're checking. And we'll be rotating at the normal speed, which is 55 for us. So we're rotating and we're allowing the aircraft to speed up to Vx, which is 65 for the aircraft that we fly in. You get to 65 and you hold that attitude and airspeed until you're cleared of the obstacles. A tree line right at the end of the runway would be a good indicator that, okay, we are cleared of the obstacles. At that point, we'll be transitioning to Vy. And after we have sufficient airspeed, flaps come up, making sure that we're not descending throughout this whole thing. And we'll go ahead and configure the aircraft for a cruise. And there's a picture of it right here at the bottom of the slide. Some common errors, people don't use the PO edge. Every aircraft has a different flap configuration for this takeoff, so you got to make sure you're checking those. We're not using the whole runway. People pulling up to the 1,000 footers or maybe even 100 feet off the end of the runway. That's not recommended. Also, using trim is very important. You're holding the nose up. It's going to take a lot of strength and power. You don't want to exhaust yourself. Use the trim properly. Pretty much a liftoff before VR, which could cause you to slam back onto the runway, and inability to maintain VX. So some hazards, we could lose our engine during this takeoff as any other takeoff, so we need to be mindful and briefed on emergency procedures here. Wind shear, since you're operating at a very low speed here, wind shear can be a huge problem. Wake turbulence if you're operating in airports with bigger aircraft, and also distractions. You're very slow and low, and you're pulling pulling the aircraft to its limits, very close to the ground. Distractions have no room. And also Philippians 4:13 says, I can do all things through him who strengthens me. Just a little sweet verse here to end the week with. Here are my references, and thank you so much for listening.